In this video, let's discuss LeetCode question 1, which is toSum, and then we'll go ahead and code it out in JavaScript. Hi everyone, let's do this question. You are given an array of integers and another integer target value. Write a function that will take these inputs and return the indices of the two integers in the array that add up to target value. Alright, now let's thoroughly understand the question first. And remember, in the interview, when this is actually happening with an interviewer, feel free to ask clarifying questions so that you and the interviewer are on the same page and that you have sufficient understanding about the question to be able to solve it. Now, in this question, it says that we are given an array of integers and we are given one more integer and it's called the target value. And we need to check whether any two elements in the array which is given to us add up to the target value, and if so, then we need to return the indices of those two integers in the array. So that's the question. All right, now let's simulate the interview by asking a few clarifying questions, and these are some of the questions that you could ask. Now let's say you're asking the interviewer, what if no two integers add up to the target value? So what should you do at that point? Now let's say the interviewer replies, okay, in that case, return an empty array. All right. Now another question which you could ask is, will multiple pairs of integers add up to the target value? And let's say the interviewer says, no, at most one pair will add up to the target value. Now, again, you could ask, are all numbers positive? Now the interviewer could say, no, there can be negative integers also. Now don't worry, it's not exactly required that probably this question may or may not have an impact on the solution, but you can feel free that if it's a valid question, if you feel that it's good to know, you can feel free to ask that question to the interviewer. And again, another question could be, are all the integers distinct? And probably the interviewer says yes, all the integers are distinct. And another question that you could ask is, what if the array of integers that is given as an input is empty? Now the interviewer says, at this point, if this is the case, then return an empty array. All right. And again, you ask, can I add the same integer twice to get the target value? And the interviewer replies at this point, no. All right. So these are some of the clarifying questions that you could ask for this question. So always feel free to ask sufficient clarifying questions to get a good understanding about the question. Now, once you have done this, let's work on some test cases. Remember, test cases are just different inputs and you write out the expected output in those cases. And in the actual interview, you can form these test cases along with the interviewer. So that's not a problem. You can always say, all right, so thank you for the answers that you have given. Now, is it okay if we work together to formulate some test cases? So you can do that. All right. Now, let's say the input array is 2, 7 and the target value given is 9. So what should be the output in this case? In this case, the output has to be 0, 1, right? Because the indices over here, this has an index 0 and this has an index 1, and we need to return the indices as per the question. Now, what if the array which is given to us is, let's say 2, 7, 3, -1 and 4, and the target value is equal to 2. Now, in this case, we can see that if we add up these two, 3 and -1, we will get the target value. So we need to return the indices of these two values. So this is 0, 1, 2, this is 2, and this is 3, right? So the answer or the output in this case should be 2, 3. Now, what if, again, the same array is given as input and the target value, let's say, is equal to 100. So there are no two values in the input array which add up to the target value. So in this case, the output has to be an empty array as per the clarification that we got from the interviewer. And let's say you have a single element as input, which is 25, and the target value is also 25. So what should be the output in this case? In this case also, the output has to be an empty array, because as per the question, we need to find two integers that add up to the target value. So again, only one integer is there in this array, so that's not possible, and we have to return an empty array. And let's say again, an empty array is given as an input, and whatever target value is given, in this case also the output has to be an empty array. All right, so we have understood the question and we have formulated test cases. Now it is time to think of a way to solve this. So we will look at two ways in which we can solve this. Now, before you go ahead and look at the solution, try to think through the problem and try to think about a way in which you would solve this. Hi everyone. So we have understood the question and we have formulated test cases. Now let's try to look at the logic or the method by which we can solve this. Now the first method that we discuss over here is the brute force method, which is very simple to understand, but probably not the best or the most optimal solution. Now let's walk through this first. Let's say the given array is 2, 7, 3, minus 1, 4, and the target value is equal to 2. All right. Now let me write the indices of the elements of the given array. So 0, 1, 2, 3, and 4. Now initially let's say we initialize a pointer and let it point to the first element in the given array. Now naturally, what is it that we are trying to do? We will be looking at, we'll keep this constant, and we will look at all the other values and see if there are any two values which add up to the target value, right? So that's the brute force method. We are just looking at how a normal person would just without any knowledge about complexity would try to solve this. So we would traverse the remaining elements over here, and let's say we have another pointer and let that be called j, and we will see whether any element at the ith index and the jth index, when we add them, whether we can get the target value. So we will check if array at ith index plus array at jth index, so this is ith index element and this is the element at the jth index, if they add up to the target value. So that's what you're checking. So we'll see if 2 plus 7 is 2 or 2 plus 3 is 2, etc. So now checking this is the same. Another way in which some people may write this is, we could also check whether j is equal to the target value minus the value at the ith index. Again, this is the value at the jth index. All right, so these two are just one and the same thing. It's just two ways of checking the same thing. All right, so we have our array over here. Now let's try to see how this spans out. So first, our index or our pointer is pointing at 2, so I is equal to 2. All right, so the value of I is 2. Now what's the value that we need? 2 plus something is equal to the target value, which is 2. So the needed value is this 2 minus what we have over here, right? So that's target value minus the value at the ith index, or 2 minus 2, which is equal to 0, because 2 plus 0 is equal to 2. So we need 0, right? So we're going to traverse the remaining elements, which are these elements which we have seen over here, and we're going to check whether we have 0 over here. So over here we have 7, we have 3, we have minus 1, and we have 4. So in none of these we have 0. So definitely there is no solution in which this is part of the solution. So we change the value of I by changing the pointer, and we point to the next element, which is 7. So the value at the ith index now is 7. Now 7 plus something is equal to the target value, which is 2. So the needed value is equal to 2 minus 7, which is equal to minus 5. So we are going to check the remaining values, which is this part over here, and we will see whether we have minus 5 in any of these places. Now notice that we are only checking the remaining values. We are not checking what came before it, right? We are not checking what is over here. Now why is that so? Because if what is over here was a solution, then it's the same. Writing the solution as 2 comma 7 or 7 comma 2 is one and the same, right? So if what came over here was part of the solution, we would have already found it in the previous iteration. But because it was not found in the previous iteration, so we don't need to check this in the next iteration. So a possible solution can only exist as a pair of 7 and one of the remaining elements. So again, we are checking for minus 5. Now we look at the remaining parts and we see that in none of these places we have minus 5, right? So again, we move the pointer of I, so it was over here, and again we move it to the next one, which is 3, right? So I at this point is 3. Now the needed value is target value minus 3, right? Target value minus the ith value, which is equal to minus 1 at this point. So we are checking for minus 1. Again, we only need to check the remaining parts. We don't need to check what came before it, because again, as we've already discussed, if what came before was part of the solution, it would already have been caught in the previous iterations, right? Because it was not caught, so we don't need to care about these values. We're going to check only for the remaining parts. Now the next value is minus 1, right? And when we see that 3 plus minus 1, that's 2, that's the needed value, right? We were checking for minus 1 and we saw that minus 1 is there in the next value. So we got our answer. 3 plus minus 1 is equal to 2. And as the question asks us to return the indices, don't return 3 and minus 1, rather than return the indices 2 and 3. And that is our answer. The answer is 2, 3. All right, now let's take a look at the complexity, at the space and time complexity of this solution, the brute force solution. Now over here you can see that with the pointer I, we are traversing the array once. So if in the array there are n elements, we would be doing n operations to traverse the array once with the pointer I. All right, now we can also see that at every iteration over here, that is for every value of I, we are again traversing the array, right? So again, we have seen that I is traversing at this point. I was pointing to the value 2, and at this point it was pointing to the value 7. At this point it was pointing to the index with the value 3. Okay, so it's pointing at the indices with the value 2, 7, 3, etc. So we were traversing the array by changing this pointer. Now at each I, we are again traversing the array. So that's what we did with the j pointer over here. And so this is another n iteration. So for every iteration over here, and again we have n iterations over here, for every one of these iterations we are doing n iterations again, right? So that's why the time complexity of this solution is O of n into n, which is O of n square. Now it's true that we are traversing only n minus 1 operations over here, and when I was pointing to the value to the index 1 and it had the value 7, we were doing only n minus 2 iterations over here. But then we just need to know the trend, right? As the time for running the algorithm, we are actually concerned with that, right? We are concerned with the larger picture. So that's why we are not exactly taking it as n minus 1, n minus 2, etc. In general, it's n iterations for every iteration in the previous traversing of the array. So that's why the time complexity of this solution is O of n square. Now what about the space complexity of this solution? We can see that we are not storing anything extra, right? We're not creating a new array or using up space. So the space complexity is O of 1, which is the same as saying it runs in constant space. So the time complexity is O of n square and the space is O of 1. Now O of n square is not a good time complexity, right? Now let's see in the next video whether we can do better than this. Now a hint that we can take away from this is we can improve the time complexity by using more space, and we'll see how to do that with the hash table in the next video. Hi everyone, I hope you have tried to code the brute force solution which we discussed in the previous video on your own. Now in this video, let's try to code it out together. Now first let's create a function, and let me call this function find indices sum. All right, so this is find indices sum, and as mentioned in the question, the input to the function is an array and the target value. Now let's have a for loop so that we can iterate through the array. So let's use a for loop for that. For let I equal to 0, I less than array dot length minus 1, because I need two values, right? So let me just show that over here. So let's say our sample array, let me have a sample array over here, which is like 1, 2, 3, 4, 5. Now let's say we are trying to find the target value, let it be 6. So we are trying to find two values, right? So the I, which is the first for loop over here, needs only to go up to the previous element, up to the element previous to the last element in the array, right? Because I will be searching matches for a particular I value, the value in the array at an ith index with something that is coming after it, right? So I just need to check I up to I less than array dot length minus 1. All right, now let's increment I, now I plus plus. Now inside this, let's have a for loop again, because this is the brute force solution, right? So let's have j, let j equal to I plus 1. So I won't be checking for every element, right? If I is equal to 1, I will check for j values for all the other values which are coming after I. So when I is equal to 1, let me show that over here. If when I is equal to 1, I will try j values 2, 3, 4 and 5. Now in the next iteration, when I is equal to 2, I will try for j values 3, 4, 5, right? So I won't check values which are coming before 2, right? Because the value before 2 is 1, and I in whatever combination is possible with 1 is already checked in the first iteration over here. So I don't need to check that over here, right? So that's why we are initializing j as I plus 1 over here, and this will go on till j less than array dot length. Now in the previous case we had array dot length minus 1, because as we saw we will go for I values only up to 4 over here. So I can take 1, I can take the value 2, I can take the value 3 in the next iteration, and 4 in the next iteration, and we'll stop over there. But when it comes to j, we will go till the end. So j less than array dot length, and let's increment j plus plus. Now inside this we are going to check if the value at the ith and jth index of the given array will add up to the target value. So that's what we're going to check. So if target value equal to array at the ith index, so value at the ith index plus array j, so the value of the given array at the jth index. Now if this is true, then we have found the answer. So we just need to return I and j. So let's return it as an array. Now if this is not true, then as per the question we just need to return an empty array, and that would happen over here, right? So this is outside the for loop. So this is outside the the first for loop. So when we are coming out of it, and if we have not yet returned anything till this point, it means that we were not able to find a combination of two elements in the array which adds up to the target value, and we are done. Now let's write a test case to check whether this algorithm is working. So let's take an example. Let's say array is equal to 1 2 3 4 5, and let's say the target value is equal to, let's say, 6. All right, so 1 plus 5 should give us 6. Now let's console log what we get when we call the function console.log find indices sum, and we'll pass the array and the target value, and let's see what we are going to get. Now I'm going to run this, and you can see that we are getting 2 0 comma 4, right? So this is 0, so that's the first element, that's which is 1, and then the element at the fourth index, that's 0 1 2 3 4, which is 5. So 1 plus 5 is equal to 6. So yes, our code is working. Now let's try a few more cases. What will happen if the input array is empty? Let's try that. So when that's happening, we are getting an empty array as the output. So that's correct as per the question. Now let's say we have 3 values, but no combination adds up to the given target value. So what happens? Again, we are getting an empty array. And what happens if I have only one element in the given array and the target value is also 10? Now in this case also we are getting an empty array, because we need 2 values that add up to 10 as per the given question. So yes, our code is working. Hi everyone. So we have discussed the brute force solution for this question. Now let's try to see how we can solve this question in a more optimal manner. Now over here we have seen that for each value of I, we were traversing the array again and again, right? So we are not storing the values anywhere. The same value which was accessed over here is again accessed over here by traversing the array, right? So this is not an efficient way of solving it, and because of that we got a time complexity of O of n square, right? Now let's try to avoid this scenario where at each I we were traversing the array again and again. So for each of these n operations we were doing n operations again, right? So that's why the time complexity was O of n square, and the basic reason for this was we were not storing anything. So let's try to store. So we are using some space, but we will try to optimize the time complexity. All right, so let's try to do that. So we have a sample input. So let's take this as the input array, and the target value is equal to 2. Now we will try to make use of a hash table to solve this, and the property of a hash table which we are using over here is that lookup, when we try to look up a value from a hash table, when we have the key, is a constant time operation or a O of 1 operation. So this is the concept that we are going to use over here, and we have seen that in the previous method we were not storing anything. Now what we are going to do over here is, as we traverse the array, we will keep storing the values in the hash table, so that later when we want to see whether a particular value is there in the array or not, and when that value is something that we have already traversed, we don't need to traverse the array again, but rather we will just access it from the hash table. We will just check it from the hash table and we don't need to traverse the array again. So that's the basic thing that we are trying to implement. All right, so let's make some space over here. Now we will have a pointer. Yes, definitely we'll have to traverse the array once. So let the pointer initially point to index 0, which has value 2, and let's make a hash table. Initially the hash table is empty. All right, now we will check what value we need along with 2 to get to the target value, which is also 2, right? So this 2 plus something is equal to the target value, which is 2. So the needed value at this point is 2 minus 2, which is equal to 0, right? Because 2 plus 0 is equal to 2. Now we will check whether this 0 is there in the hash table, and because again we are starting the algorithm, so at this point it is not there. So if it is not there, in this case 0 is not there in the hash table, what we will do is we will insert this value into the hash table. So we'll insert 2 into our hash table. Now let me do that. And again, because the question says that at the end we need to return the indices of the values which add up to the target value, so when we insert 2 in the hash table, 2 is going to be the key and the value is going to be the index. So at this point we're going to insert into the hash table 2 0. This 2 is this value, and this 0 over here is this index. So the pair, the key value pair that we are inserting over here is 2 0. So notice what we are doing over here. We are storing the array into the hash table, right? So we don't need to traverse the array again to see whether we have 2 or not in the array. So that's the basic thing that we are trying to do over here. All right. Now again, we move the pointer from 2 to the next index, which is 7. Now what is the needed value at this point? 7 plus something is equal to 2. So the needed value is 2 minus 7, which is equal to minus 5. So we are going to check whether minus 5 is already there in the array. And for that, we are not going to traverse the array, but rather we'll just check whether minus 5 is in the hash table or not. All right. So at this point, minus 5 is not there in the hash table, right? It's not there in the hash table. So what do? We insert this 7 into the hash table. So that's what we're going to do. We're inserting the array elements into the hash table. So let's insert 7 and 1. So this 7 is the value of the array, right? This is the key of the hash table, but that's the value which you have in the array. And over here, this 1 is this index. All right. Now let's make some space. We move the pointer from 7 to 3. Okay. So again, 3 plus something is equal to 2. So we need minus 1. We are going to check whether minus 1 is in this array, not by traversing the array, but by checking whether it's there in the hash table. All right. Now you can see that minus 1 is not in the hash table, right? Minus 1 is not in the hash table. So what do? We insert this 3 into the hash table. So that's 3, 2. 3 is this value and 2 is the index, which is this one over here. So we insert 3 and 2 into the hash table. Now we again move the pointer and we have minus 1. So minus 1 plus something is equal to 2. So the needed value in this point is 2 minus minus 1, which is equal to 3. And we are going to check whether 3 is already there in the array, not by traversing the array, but by checking the hash table. And when we do that, we can see, yes, 3 is already there in the hash table, which means that 3 is there previously in the array, right? So yes, we have found our solution, right? This means 3 is there in the array. So we have the answer. And remember, we need to return the indices. So the index of value 3 in the array is this 2 over here. So we are going to return this 2 and this index over here. Already we have the pointer which is pointing to index 3, right? So we are going to return these two indices, this 2 and this 3. That's 2, 3, which is our answer. Now again, quickly, let's revise what we did. Basically, we are ensuring that we need to traverse the array only once. And whenever we encounter an element of the array, we check whether the needed value is already there in the array, because it's a pair, right? We need two values. For example, 2 we needed 0, for 7 we needed 5, for 3 we needed -1, etc. So when we were at the index which had the value 2, we are checking whether 0 is already there in the array, not by traversing the array but by checking the hash table. Similarly, when we were at the index which had the value 7, this one over here, we were checking whether 5 is already there in the array by checking whether it's there in the hash table, and if it's not, we were inserting, right? So at this point we inserted 2 0, then we inserted 7 1, at this point we inserted 3 2, and when we reached over here, we checked whether we have 3 in the array, in the previous elements of the array which were already traversed, not by again traversing the array but by checking the hash table, and we saw it's there, right? So we got the answer, and the answer is -1 and 3. These add up to 2, and we return the indices because we are storing the index over here. We got the index of 3 from the hash table, and the index of -1 we got it because that was stored in the pointer, right? So we return 2 3, which is the answer. Now let's look at the space and time complexity of this solution, right? So the time complexity of this solution is O of n. We have seen that the time complexity of the brute force solution, where we had two for loops, right? So there was a nested for loop. The time complexity was O of n square. So we were able to improve upon that to O of n. Why is that so? We are traversing the array only once, right? We are traversing it only once, which is what we have done, which is what we are doing over here. And remember, accessing from the hash table when we know the key is a constant time operation. So checking whether it's a particular value is in the hash table, and if it's there, taking the index is a constant time operation. So that's not adding to our time complexity. So the time complexity over here is O of n, and the space complexity over here is also O of n, right? Because max we need to insert n pairs into the hash table, right? Let's say we have these 5 elements. So in the worst case, our hash table will have 5 pairs, right? 2 0 7 1 3 2 -1 and 3 and 4 4, right? So that's the worst case scenario, and this is n elements. So if there are n elements in the input array, the hash table will have at the most n pairs. So that's why, because we are storing this extra hash table, that's why the space complexity of this solution is O of n. So in the brute force solution, the space complexity was O of 1, but by increasing the space used to O of n, we were able to improve the time complexity. In the brute force solution, it was O of n square, but we were able to improve it to O of n. Hi everyone, I hope you have given it a shot. Now let's code together the solution that we discussed in the previous video. Now for this, let's start by creating a function, and let's call this function find indices sum given. And as mentioned in the question, we pass the array and the target value into this function. Now we are going to initialize a hash table. That's how we are going to avoid the need for 2 for loops, which was costing us a lot of complexity, which was increasing the time complexity. So let's call this hash table itself, and initially this hash table is empty. Now we need to traverse the array once. For this we will use a for loop, but before that, let me just create a variable needed value. We will use this to check whether the needed value is already there in the hash table. Now for traversing the array once, we are using the for loop. So let's write for let I is equal to 0, I less than array dot length, because we need to go through the complete array, right? So we are doing it up to I less than array dot length and I plus plus. Now inside the for loop, first let's calculate the needed value. Now again, over here, let me just show what's happening. Let's take an example. Let's say the given array is again 1 2 3, and let's say the target value is 3. Or let's take another example. Let's say 1 2 3 4, and let's say the target value is 7. So let me write that. So target value is equal to 7 to make the logic clear. Now we are inside the for loop and I is equal to 0 at this point. Now in the 0th index, the value in the given array is equal to 1. Now we are going to calculate the needed value at this point. So the needed value is nothing but the target value minus the value that we have, right? So needed value is equal to target value minus array at I. Okay, so in this case we have array at I is 1 and the needed value, let me write that as NV, needed value is equal to 7 minus 1, which is equal to 6. Now we are going to check whether this 6 already occurred before. Now we are starting with this iteration, so yes, it does not make sense because it's going to be empty anyway. The hash table is empty, but going forward this is what we will be repeatedly doing in each iteration. So let's do that over here. We're going to check whether the needed value is in the hash table. So if needed value in hash table, so if it is there, it means that it already occurred in the array before, right? So we have found the answer. Now if it is there, we're going to return the indices, the required indices. Now in this case, the one index is I because we are at the ith value, right? And the other index will be stored as the value when we pass the needed value as a key in the hash table. All right, so let's just hold this for a minute and let's write the else part and come back so that it will be clear, because we have not yet written what comes into the hash table, right? So let me just leave that for a moment and write the else part. So if the needed value is not there in the hash table, what do? We insert the value. We insert a of I into the hash table. So let's write that hash table at a of I. So the key is array of I. The key is the array, the value. In this case, the key is 1. So 1, 2, 3, 4. These are going to be the keys in the hash table. And the value will be the index, because we need to return the index at the end of the day, right? So we need to be able to read the index from the hash table. That's why we are storing the value as the index and the key is the value of the array. So in this case, we are going to store in the hash table. Let me write that also over here. So in the first iteration, when array of I is equal to 1, we are in the hash table. Initially the hash table is empty. Now at this point, we are going to see that the required value, needed value, which is 6, is not there in the hash table. So let's store 1 in the hash table, and we also need to store the index of 1. So we are going to store 1 and 0. So 1 is the value, this one over here, and 0 is the index. This is at the 0th index. All right, so we're going to keep doing this. Now in the next iteration, so over here you can see if needed value, so let's just complete this part which we left for a moment. So when the needed value is in the hash table, that means, let's say over here we are at 4. Let's say we have traversed till 4. Now let me just write that over here. What would be the hash table at that point? It would be 2, 1 and 3, 2, right? And then we are at 4. So array of I is 4. Now at that point, the needed value will be equal to 7 minus 4, which is equal to 3, right? And we will see that it's already there in the hash table. It's there, right? So we know that it already occurred. So that's the case which we are writing over here. At this point, we need to return the indices. So one index will be I, which is the index of 4 in this at this point, and the other case would be the value at the key of 3 in the hash table, right? So we need to take the value by passing in the key. So let's do that, hash table, and we're going to pass in the value as needed value. So we're going to return this at this point, and there we have our solution. Now the only thing that remains is, if we come out of this for loop without returning anything, that means we were not able to find a pair that adds up to the target value, and we will return the empty array. And there we have our solution. Now let's go ahead and test whether our solution is working. For this, let me say array is equal to, for example, 1, minus 2, 3, 4, 5, and let's say target value is equal to, let's say 3. Okay, now let's console log what we get when we call our function. So we have find indices sum given, and we are passing the array and the target value. Now let's see what happens. So I'm running this. Now when we run this, you can see that we get the array 4, 1 as output. So index 4 is 0, 1, 2, 3, 4, which is 5. So value 5 is at index 4, and at index 1 we have -2, right? 0, 1. 5 plus -2 gives us 3. So yes, our algorithm is working. Now what if I pass an empty array and let's run it? So I get an empty array as output, so it works. If it's a single element array, again I get an empty array which works. And let's say I have 3 comma 9 and the target value is also 12. If I run it, I'll get the answer as 1 comma 2. So yes, our algorithm is working. To master data structures and algorithms step by step, check out my best selling Udemy course on DSA with JavaScript. In this hands-on, in-depth course, you will explore and practice core data structures, algorithmic techniques such as backtracking, dynamic programming, greedy algorithms, etc., essential patterns such as sliding window, two pointers, merge intervals, and tons of LeetCode coding questions to solidify your problem-solving skills. Each topic is broken down into bite-sized lessons with animations, relatable examples, and step-by-step coding demos, ensuring even the most complex concepts are easy to grasp. By the end of this course, you'll have developed deep confidence to tackle DSA questions successfully. To know more about this course, click on the link in the description and take your DSA prep to the next level.